For number one, we have a airport, factory, shopping center, vertices of a right triangle. All right, I'm working with the right triangle. Perfect. So let's get a right triangle out here. Somewhere here, right triangle. There it is. Let's open up the right triangle. Okay, I don't know which vertex is which yet. I'll keep reading. The airport and factory, 6 miles away. The distance from the shopping center, 3.6 and 4.8. Okay, got it. I don't know which vertex is which yet, but I do know where the 6 goes. Why on the hypotenuse? It's the longest side of the right triangle up there. So that's 6. And what's that 6 represent? That's the distance from the airport to the factory. So airport, factory. Doesn't matter if you put factory or airport, but at least I know at the right angle is the shopping center now. If the distance from the airport to the factory is 6, I know at least the shopping center is the right angle. All right, what about the other two sides? Here we go. Their distances from the shopping center are 3.6. Now, when they go to this respectively, I'm sure you've seen this before, but when they go to the respectively, that means in order. So look how I got the airport first. So that must mean from the airport to the shopping center is 3.6. And 4.8 is from the shopping center to the factory. All right. And we're going to put a service road in. The service road is going to go from the shopping center to the highway that connects the airport and the factory. So here's my service road. From the shopping center to the highway that connects it. What is the shortest? And I'm not expecting you to know this. If I gave this tomorrow, I would definitely put a diagram in already labeled for you. But the shortest possible distance, we've talked very, very limitedly, but the distance from a point to a line is the perpendicular distance. All right, if I want to measure the distance from a point to a line segment or a line, it's the perpendicular distance. So how long is that service road? Again, I'm not going to write in any degree measures. I have no idea what the degree measures are here, and I'm not going to guess. But here we go. What type of triangle is ASF? Right triangle. What is the service road acting as? An altitude being drawn to the hypotenuse. Automatically, if I have that, that signals what type of problem? Hills and SAS. Yes, hills and SAS. But you'll find out that, okay, it's hills and SAS, but it's not as easy as it looks. Again, what's the service road acting as? Altitude. So right away, I wouldn't blame you tomorrow if you said, hey, got to use SAS. Because that's the only one that's got an altitude in it. Here's the problem. You're going to put X and X. Do we know what the segments are? No, so you cannot fill this in right now. Does everyone see that? I cannot fill in SAS right now. What are you guys missing that would help you out in here? What are you guys missing that would help you out? The two segments, right? Once you knew the two segments, you're good to go. Can you find the two segments so I can plug them back in? Can you find either segment so I can plug it back in? What's the other device that we have? What's the other device other than SAS that we have to use? Hills. What's hills have in it? A segment. Yes? So we could solve for the segment, go back and plug it back in. Well, let's see. Do we have enough information for hills? I'm going to ask you guys now. What's the H stand for again? Here we go. 15, which is 6. L is for leg, and you got both of them. Pick your poison. Which one do you want to use? There's not a right or wrong. There's not a wrong answer here. 10. 3.6. Well, I guess there is a wrong answer if you gave me 6. But what do we know about the legs and hills? They're mean, so they are the same. And if you guys are going to pick 3.6, this is the segment we're solving for. I'll call it Y because I already called the altitude X. Okay, find one of the segments then. What do you have there for the segment? 10 when you're ready. 2.16. Hey, yep. That's this one right here, 2.16. That would take care of one of the segments in SAS. And remember, they're different ones, right? So I still need to find the other segment. Do I have to do hills again? What's a quick way I could just find the other segment length if I know the first one's 2.16? Here you go, 8. Okay, subtract it from 6. And when you're ready, let me know the other segment length. A little raspy today there, Ava. It's fine. It's okay. Guarantee the generator will find you again. Because it's ruthless, just like its user. Everyone all right? Now do we have enough information to find the service road? All right, here we go. So segment 2.16 over altitude equals altitude over other segment 3.84. There are rounding directions at the bottom, at the end of the problem, so take a peek at those before you let me know what the right answer is. Length of the service road, 15, 2.88. Tomorrow, right now, if your problem has units in it, so does your answer, please. So 2.88 miles for the shortest length of the service road. We are right there. I know I came strong very first problem, but I want you to just don't be in the habit of, oh, I do a SAS and I'll fill it in, everything will be grand. Maybe you won't have enough information. Maybe you got to go to Hills to find out some more information. Anything before we go on? Go, ask away. Yep. Oh, after you find the 3.84, yes, you can. But at the very beginning, because at the very beginning, all you had was X and 4.8. You didn't have that other side. At the very beginning, you just had X and 3.6. Didn't have the other side. Okay, so at the very beginning, no, you could not use Pythag, but once you found one of the segments here, then you could say X squared plus 3.84 squared equals 4.8 squared. Okay, after you found one of the segments, though. Anything else? Good question. Okay, I'm going down to the hexagon problem 5. Blow this up so I can. 2 reasons why I love this problem. 2 reasons. One is it's going to review a special type of right triangle we need to review. And the second is it uses the word snugly. All right, which I don't know how often we see in a math problem. It will not be the last time you see the word snugly either this year. Okay, but if you're wondering, those box of chocolates, snugly inside the rectangular box. All right, now that we've gotten over our snugly obsession, it's a regular hexagon, so all the sides are the same. Perfect. Rectangular box, so what's the angles here for the rectangular box? 90-degree angles, yep. All right, we're working towards something. And right under the box, it says each side of the hexagon is 3 inches. So one side's 3 inches. They're all 3 inches because it's regular. Got it. What's the dimensions, length and width? That's what I'm looking for, length and width of the box. All right, do not pop in angle measurements unless you are 100% sure it's a certain angle. So how do we get other angle measures? Because Pythag's not going to cut it. Sorry. I know 3, and that's all I know. All right, so Pythag isn't going to cut it. Any other way we could find some other angles? Hello, Zach.
Hello. We're probably going to have to find the measure of the interior angles.
So you want to find the interior angle? How's that going to help you?
Well, because it's linear pairs with one of the
So why don't we shorten this up? Why find an interior when you can just find the exterior? Because I know all the exteriors add up to what? 360. So if I wanted to find an exterior angle, I could take 360 and divide it by, how many do I have here? 6, and that would tell me an exterior. Look at that magic number that pops up. 60 degrees for an exterior angle here, meaning the other one's got to be 30. All right, 30, 60, 90. Let's do it. Almost started writing the rules down. What are the rules in a 30, 60, 90 triangle? How about number 4? What are my rules?
30 is x, 90 is 2x, and then 60 is x.
You got it? Where's that 3 across from? 12, where's that 3 across from?
The 90.
The 90. Can you guys fill in the rest of the chart? Because I'm going to need both those sides, the one across from the 30 and the one across from the 60. Can you fill in the rest of the chart now? What's across from the 30 and the 60 now? Across from the 30 and the 60. Number 1, what's across from the 30? And how about the 60? All right. So let me go in, fill in my diagram a little more. 1.5 across from the 30 and 1.5 radical 3 across from the 60. Got it. I need to know a little more though, because if I'm going length and width here, or width, length and width, however you call it, right, I need to know a little more here. All right, so let's go to those other triangles. What's this angle measurement going to be right here? It's also an exterior, so that's 60. That's 30. So we know we already determined the side across from 30 was going to be 1.5. All right, got to go along the vertical side now. What's this one going to be here? This angle measurement? That's the 30, yep. Here's the 60. So that missing side I needed would have been 1.5 radical 3. All right, let's find the dimensions. Let's start with this one. I don't know whether you call it length or width. I don't know. Let's find that dimension right there. How long is that side? We're looking at what here? 15? 6? How'd you get it, Grace? Because some people see the 1.5 and 1.5 and they're like, how'd you get 6?
Oh, I just added all.
Yep. 1.5, 1.5, and don't forget the side of 3. So 1.5, 6 by, let's go on this side now. Let's go on the vertical side. By, how long is this side right here? 19? 3 radical 3, yep. And this is in inches, correct? So make sure we have inches there. So it's 6, or 3 radical 3 by 6. I would take either one. Any questions on the chocolates there? Now you're going to finish the review on that packet. The answers to those are with the answers to tonight's homework on Aspen. Okay, they're on the same file. All right, if you're having issues, let me know. I will let you know, so there's no arguing, that on number 2, that yes, the dock is perpendicular with the ground. Okay, the dock is perpendicular with the ground. All right, you're on your own. You can move around and work with other people. Have an answer key available to you as you finish up the packet. Once you finish the packet, grab a book.